So in this question, we're given this condition that needs to be met, where both m and n are positive integers, and they're asking us to find the least possible value of m plus n. So clearly, since we're just adding them, we want to reduce both m and n. You'll notice this is n cube, which means that if I can find a number m, the least possible value, that makes this a perfect cube. Because notice this needs to be in that cube form. So it all rests on the prime factorization of 75, which is 25 and 3, which is 5 squared. So if we look at the prime factorization, this is what we have. And we need to choose something for m so that this is a perfect cube. So you'll notice that if I introduce a 5 in m, then this would become 5 cube. And then if I introduce 2 more 3's in m, then this would become 3 cube. So essentially, if I replace m with this term, this is going to become 3 cube times 5 cube. So it will become a perfect cube of 3 times 5. And that would be the least value. So essentially, you had to just look at what was missing in these other numbers, that if I were to add those in m, it becomes a perfect cube. And that's driven by this form. So the least possible value of m is 3 squared times 5, which is 45. And then n, you'll notice n, it's 3 times 5 cubed, which means n is 3 times 5, or 15. And therefore, the sum that we're looking for of these two numbers is 60, which is choice D.